So consider two lines. Line 1 has a gradient of m1 and line 2 has a gradient of m2. We know the following things about the lines. If the lines are parallel, it means that they're going to have the same gradient, which means that the m1 would be equal to the m2. So if ever you find two gradients that are the same, it means that those lines are parallel. However, perpendicular lines. Perpendicular lines are lines that make a right angle or at 90 degrees to each other. To find perpendicular lines, their gradients will multiply to give -1. So there's two ways that we can write this formula. Mum, it's 3 people that have walked in late. We can write it as m1 times m2 equals -1, or you would use that version if you were trying to show that lines were perpendicular. So you'd times the two gradients together and you'd get a -1. If you had one gradient and you're trying to find the one that was perpendicular, you would use this one. So you'd sub in the m1 on the bottom of that fraction and it would tell you the perpendicular gradient. It is always the negative reciprocal. You'll kind of learn it. There's a bit of a shortcut to that formula there. Okay, so let's have a look at the questions. Number 1. Are the lines y equals 3x plus 1 and y equals -1/3 x minus 5 parallel, perpendicular, or neither? So I need to know the gradients of both of them. Now, if they're in y equals mx plus b form, we can just read the gradients straight off the equation, and they are. So for this first equation, right in front of that x, that 3, that's going to be my first gradient, so I'm going to call that m1 equals 3. The second equation is also in y equals mx plus b form, so that number there will be my m2, which is -1/3. Now we can see straight away that those gradients aren't equal, so the lines are not going to be parallel. But are they going to be perpendicular? Let's use our formula to double check. The first formula was m1 times m2. If I times those two gradients together, m1 was 3 and m2 was -1/3. And when you times those together, you do get a -1. So by timesing those gradients together and getting a -1, that means that they are therefore perpendicular. Okay?
So if the answer is -1.
If you times the two gradients together and you get a -1, it means they're perpendicular. If you get anything else, it means they're going to be neither, because we've already ruled out that they're going to be parallel as well. Question 2. Are the lines y equals half x plus 6 and x minus 2y equals 4 parallel, perpendicular, or neither? So very similar to the first question. The first equation is already in the right form. It's y equals mx plus b. So I can read off my m1 is equal to a half. However, the second equation is not in the right form. I need to get the y by itself so I can read off that gradient. So we need to do some rearranging. First of all, the 2y is negative. It's always easy to make that positive for a start. So I'm going to add the 2y across to the other side, which would be x equals 4 plus 2y. Then I'm going to subtract the 4, which would be, I'll write the little instructions underneath for those of you who still like them. 2y, I'm going to put that on the left, equals x take away 4. So I've just switched sides so that my y is on the left. And now I can divide everything through by 2. Now there's two ways you can write that. Either you could go x over 2, or knowing there's a 1 in front of that x, it would be 1 over 2x minus, and 4 divided by 2 is 2. So I've divided each term by 2. Does that make sense? Okay, now it's in y equals mx plus b form. So my gradient, which is going to be the m2, because it's my second line, is going to be that half that is there. Now, M1 was a half and M2 is a half. So what does that mean? The lines are parallel. So I would write M1 equals M2, therefore they are parallel. Number 3. Are y equals a quarter x and minus 4x plus y equals 1 parallel, perpendicular, or neither? Same thing again, we need to find the gradients of each line. First one is already y equals form, so the gradient is going to be that number in front of the x, so m1 equals a quarter. The second equation, again, I'm going to have to rearrange, and the x is negative this time. So let's move the x across to the other side, making it y equals 1 plus 4x, because I've moved it across the other side. Okay, now I know the x is in the second position, but the gradient is always what's in front of that x, as long as the y is by itself. So m2 is going to be equal to 4. Now, the gradients are quarter and 4, they're not the same. So then we check to see if they're going to be perpendicular by timesing them together. M1 times M2 is going to be a quarter times 4, which makes a positive 1. Unfortunately, a positive 1 is not perpendicular, it needs to be a negative 1. So that means, therefore, it is a neither. All right, next page. Now for a slightly different type of question. So hopefully getting the idea, gradients are equal, they're parallel, gradients times to give negative 1, they're perpendicular. Next type of question, number 4. I want to find the equation of a line that is parallel to y equals 2x plus 5. Now, all I need from that y equals 2x plus 5 is the gradient, because parallel means that it will have the same gradient as that line, doesn't it? Yes. So it's already in y equals mx plus b form. So the gradient is going to be that 2. And there's only one gradient in this question. I'm not comparing it with another one. So I can just call that m. You can call it m1 if you want to, but there's not going to be a second one. So if I know the gradient is 2, and I'm also given this point, 1, 3, I can find the equation of the line using the point gradient formula that we learnt about last week. Y minus y1 equals m bracket x minus x1. And we just have to sub in. So the x1, y1 comes from the point. Y take away 3 equals m is 2, x take away 1 for the x1. We always want to expand it out and get y by itself. So expand the brackets. 2 times x is 2x, and 2 times negative 1 is negative 2. Last step is to add this 3 to get rid of that, so that y is by itself. Y equals 2x minus 2 plus 3 is a plus 1. So that is the equation of a line that is parallel, because you can see it's parallel. It's y equals 2x plus 1, and the other one was 2x plus 5. They just have a different y-intercept, but they both have the same gradient. Question 5.
So what do you do?
That's it. We found that's it. That's the answer. We're after that equation of a line that is parallel to the one we were given, but this one that I found is also going to pass through the point 1, 3. Question 5. Find the equation of a line which is perpendicular to y equals 2 over 3x take away 1, and it passes through the point 2, negative 5. So very similar to question 4, except for we're doing perpendicular instead of parallel. So like we did last time, I'm going to start by getting the gradient from here, and I am going to have to call that an M1, because that would be the gradient that is parallel. If I was doing parallel, like in question 4, that would be the gradient that I would use. But this time I want the gradient that is perpendicular. So I want to find the M2. Now this is when that second formula for perpendicular lines is useful. Trying to find the M2, it's negative 1 over M1, which if I substitute in 2/3 into there, it would be negative 1 over 2/3. Now a fraction in a fraction, a 1 over 2/3 is going to flip the bottom fraction upside down, and it becomes negative 3 over 2. You can type that all in your calculator though, if you don't like doing that in your head. You just type in 1 over 2/3, but all it does is turn that bottom fraction upside down.
Can't we just flip it?
Yeah, that's what I'm saying. Yeah. So for a bit of practice, yeah, that one's 2 over 3. This one here is a 2 over 3, so it becomes a 3 over 2. You flip it. Bit of practice, if I gave you a gradient of, Charlotte, if I gave you a gradient of 4, what would be the perpendicular gradient? Negative a quarter, good. How about a gradient of negative a third? What would be the perpendicular gradient? Oh, Ruby, you're good at this. 3. Okay, so you get, everyone else understand, other than Ruby, right? Another one. What would be the perpendicular gradient to 5?
1 over 5.
Not quite. Negative 1 over 5. So whatever it is, if it's a whole number, you're going to have to you need a 1, and you're going to need to turn it upside down. Yeah? All right, anyway, we have found our perpendicular gradient. So now we want to find the equation of the line using our point gradient formula again. So read the questions carefully. Some questions might say just find the gradient that is perpendicular, and that's what I've done in orange. But if it wants the equation, I still have to use this to find the equation of that line. So my x1, y1 comes from the point, and I sub them in. Y take away minus 5 will become a plus, because 2 minuses become a plus. My perpendicular gradient is negative 3 over 2. Bracket x take away 2 from the point. And we just want to expand that out. So y plus 5 equals negative 3 over 2x. Minus and a minus will make a plus. 3 over 2 times 2 becomes a normal 3. And last thing to do is subtract the 5 to get the y by itself. Y equals minus 3 over 2x, and 3 take away 5 is minus 2. All right, and that's what we're practicing today.